So hello, welcome to the course, and this is a 12th lecture. Yes,
Hi, hi Shubham.
I. So I hope you enjoyed your
Deep
vacation. It
Vacation.
was a,
Yes.
yeah. So yeah. So today we are beginning with a very important concept in not only Python but programming languages as a whole. This concept is known as object-oriented programming. So Python is actually an object-oriented programming, and if you have studied Java, then Java is also object-oriented programming. In this, what we do is we actually wrap data in terms of objects. All right. So I'll just read a few of the points which I have written, and then we will see some examples which will more solidify this concept of object-oriented programming. All right. So uh, in earlier classes also I have told you that everything in Python is an objects. So whatever data type we have studied, like integer, float, string, lists, dictionaries, even functions, everything in Python are objects. All right. So Python accommodates various data types including these, and also it supports composite data types. So composite data types, we have seen the dictionary is a composite data type, lists is also a composite data type, and others like sets, etc. All right. So in real life, we call something an object. So those objects in real life can have some features, it will have some name, it does some functions similar to those in programming also. When we say something is an object, it has to have these three things. First, it has to have a type. So when we say list, then it is an object, it is of type list. So suppose I say lst1 equal to, and I give a list 1, 2, 3, 4, and 5. So this is a list. And when I check what is the type of this object, when I say print um, type lst1, then we see that it is actually a list object. All right. Now you can ask what is this class? So we'll come to what class is in a little while, but just for understanding purposes, I have shown you that this object, whatever it is a type of list. So this type is the attribute to an object which says what it does, what will it do, what are the features of the object. So this is what type means. All right. So when I say type int, it will show you it is an integer. So just let me show you. Um, if I say a equal to 2 and I say print type a, then it will give you class int. All right. So this is what type means. Now it has some internal representation of data which can be primitive or composite. So what it means, you see, when we are talking about list or any other object for say, but for example, we are talking about list, then these have some representation details. So how do we represent a list or any other object? So if I say that a cat is an object in Python, so I want to create an object in Python that is employees, for example, employees of a company. So what data will be represented by when we call employee, that is known as representation of the data. So employee can have a name, it can have an employee ID, it can have salary, quantity of salary it is withdrawing from the company, etc. So those internal representation is actually what is known as at one form of attribute. So what are the different form of attributes of an object, we will see a little later. And an object has functions in it in which we can interact with those object. So suppose we have lists, so we have seen some methods for lists like extend, append, etc. So these functions or methods. So in today's class we will see what is the difference between a function and method. But when we are talking about objects and functions on that object, we will call it a method. So append, extend are methods of lists. All right. So these methods are specific to that object, and we will see how it is specific to that object, and we will also define our own object and we will define methods for that object. and those methods will be applicable for those objects for which it is defined. All right. An object is essentially an instance of specific type. So what does this mean? You see, when I'm saying LST1, so this is a one object of type list. All right. So the object type is list, and for that object type, list object type, LST1 is an instance of that object. So this is one object. LST1 is an object. And what is the type of this object? The type of this object is list object. All right. So this is what this line says. An object is essentially an instance of a specific type. Yes, Ram Prakash.
No, no, it's okay. Because I thought someone will join. As it's just two of us, I thought I'll open the mic.
Oh, no problem. Sure. So it's saying, for instance, the integer 1, 2, 3, 4 is an instance of an int object. Similarly, when I said LST1, so LST1 is an instance of list object. And this instance is known as an object. So LST1 is an object in memory. All right. While hello is an instance of string type. So this is what I'm talking about. All right. Now we have seen when we say type LST1. So when we are saying type LST1, we are getting the type of the object, which is list. All right. Now you can go further. There is a function which we have discussed a little bit earlier, which is known as isInstance. So you can say print isInstance, and you can check if an object is of that particular type. So you can say LST1, comma, and you have to pass the type of an object. So I am saying LST1 is an object and LIST is an object type. Yes. Anything?
No, no, I'm just
All right.
following you.
Yeah, so it is LST1 is an object and list is an object type. So it will say true. All right. So this is how we check if an object is of a particular type. So this term type is important. You have to understand what type means. All right. So when I say this, I'll just comment and write something here. The type of object LST1 is it is class list. All right. So it is actually a list object. Now, when I say print list, now you see we are saying that print a object type. When I say print an object, hello Pratibha and Ashok, you are late here, so I'll just repeat because this class is important and starting point is very important when we move forward. All right.
Yeah.
So in today's class, we are talking about object-oriented programming. And what does this mean? You will see examples and you will get a better understanding. But the thing you have to understand is an object in Python is something which has some features, some attributes to it, and you can create some instance of that object type. So I guess it is complicated. For simplicity, you say that we are talking about list. So when I say LST1 is something like this, so we are defining LST1, which is this value. Now, when I check what is the type of LST1, it says class list. All right. So LST1 is an instance of class list or object list. All right. And list is a type of object. So you can have different types of objects. You can have float objects, integer objects, string objects, list objects, tuple objects, dictionary objects, function objects, etc. So this LST1 is list type object. So that is what it is saying. Print type LST1. Now there was a function which we have discussed a little bit earlier called isInstance. It is just checking if LST1 is of type list. This is what I had discussed earlier, but in today's class, I'll define isInstance in a little bit different terms. So you see, LST1 is an instance of object type list. What is an instance of object type? You see, in Python, I told you every object has a type. All right, every object has a type. Now, LST1 has a type of as an object type of list. So it is a list object. All right. And LST1 will be known as an object. So whatever in Python is known as object. So LST1 is an object of object type list. So is instance is checking is LST1, which is an object, is of type list. All right. This is object type and this is an object. So it is seeing if this object is of the object type list and it is returning true. All right. Now when I say print list, what it will print, you see, it is saying that list is a class. Actually, this means that a list is a class. Now, what is a class? Class is actually an implementation of objects in Python. So when I say class, it means that we are implementing the concept of objects in Python using class. All right. So list is a type of class. So it is hierarchical. So list, which is an object type, is of the type class. All right. So it is getting confusing, but bear with me. All right. So list is an object type which is defined by using class. All right. So we have talked about object, object type, and classes. Now, since you have come late, so I'll also say what objects have. So objects can have representations. So you see, when we are talking about list, we say that it is represented like this. But this is not the correct representation. This is what we are seeing, but how it is implemented internally, you will see with a diagram. So this is how a list inside the class is defined. So how a list is defined. One index of a list has two values. First is the data, and the second is the index of the next index. So what I mean, so you see, I have taken a image of linked list. So it is similarly how list is implemented in Python. So this is a list and the first, so this is the zeroth index, this is first index and this is second index. So in the first index, it will have a data, whatever the value of that instance is, and the second part of that value will be the address of first instance. So first, sorry, index. So this will hold the index of or memory location address of the next index. So suppose this has a memory location of 142. So next we'll have the value of 142. All right. So this is why it is linked. So this value is linked to this value. Why? Because this memory location is stored here. Similarly, this memory location, wherever it is stored in the memory, is stored in the previous cell. All right. So this has the value, whatever the value of the list is. So you see, I have a list which has the value of 1 in the zeroth index. And this will also store the memory location of this index, which has a value of 2. Similarly, this will store the memory location of the index 2, which has a value of 3, and so on. This is how the internal representation of the data in list is defined. All right. So we will talk about this. When we create our own objects, we have to say what are the representation of data. But for understanding, I have shown you how lists internal representation is defined. Now, an object can have methods or functions or something which will help you interact with that object. All right. How are we interacting with that object? We will see just now. All right. So I have created it in a sequential manner. So we'll proceed and we'll see how we interact with an object. But we have learned how we have interacted with an object. So for a list, we can interact with that list using the methods of that list, like extend, append, len. Len is the length of the list, and so on. So those are the methods in which you can use these methods and interact with that object. And these methods are very specific to that object. So these methods are defined for that particular object type. So when I say extend, so extend is defined for the object type list. All right. Now in Python, everything is treated as an object. and you have the ability to create a new object of certain type. So it can be of any type. Suppose you want to create an object called employee, and you want to have the values, or so some attributes of that employee, such as employee name, employee address, employee phone number, and so on. So you can create objects, and those will have some attributes, and you can interact with those attributes. You can change the salary of the employee, you can check the salary of the employee. These are the ways you are interacting with that object. All right. And when you're creating an object called employee, it will have an object type of employee, and we will see how we will define an object type, how we will define the attributes of the objects and the functions of that objects, and etc. All right. Objects can be manipulated according to their types. So this is what I was telling you. The type of the objects says what functions you can use with that object. All right. Objects can be removed from the memory. So we have seen del keyword. So I have defined a list called lst1. When I say del lst1, then it will delete lst1 from the memory. And when you check lst1, it will give you an error because that is not defined in memory. Right. Uh, so what are objects? Objects serves as data abstraction that encapsulates an internal representation. So this is what I'm talking about from so on. So it has a data representation. So what are objects? It is a form of storing data. You are storing some data in some form. And you see, when I say employee object, why are we creating an employee object? This is because you may have a lots of employees, and all those employees will have similar attributes, similar methods you want to use for the object. So you create an object type called employee, and you create instance of that object type, employee 1, employee 2, employee 3, and those objects will have similar attributes, and you can perform some operations between those objects and so on. All right. So what are objects? Objects are actually data abstractions. In a way, you are gathering, not gathering, you are creating some form of data structure in your memory, and you're using those data structure again and again. Yes, Pratibha. Yes, yes, yes. You can speak. Hello, am I audible?
Yes, Shubham, you're audible. I can hear you.
Pratibha, do you have any questions? All right. If you have any question, you can pause me anytime. Huh? All right. An interface for interacting with that object. So I have told you, there are some methods in which you can interact with that objects. You can define some behavior, or we will see. All right. Now I have shown you a diagram of a linked list. So this is how lists are implemented. And I have told you, you can interact with that object or manipulate the object using some of the functions which we have seen. So suppose I have a list one as list range 7. And when we do so, then there is a list in one in memory, lst1, and it has the values of this 0, 1, 2, 3, 4, 5, 6. We can interact with that object as we have seen earlier. So we can use len lst1, and we will get the length of the object. So these are all defined inside the object type called list. So these functions are defined inside that object type. Similarly, min function is defined, or method. If I'm saying function, I'm referring to method. So what is the difference between function and method? I'll repeat again. A method is a function which is defined for a particular object type. All right. So that is when it is called method. So when I say min, so min is a method for that object type list. So min lst1 is defined, and it gives the minimum value in the list. So it will give you 0 and so on. We have seen all these methods, l dot sort, l dot reverse, l dot remove, pop, insert, index, count, extend, append, etc. All right. Now you see, you can create an object in memory. So I have created using your own classes. No, before that, yeah, before that you can create an instance of an object using two um, ways. All right. So when you say lst2 is equals to 2, 3, 4, 5, 6, and so 7. So this is a way of creating, sorry, not dot. So dot shouldn't be here. This is a way of defining a instance of list. So you defined an instance that is an object of object type list this way. You can also do that using the list keyword. All right. But here, when you are using list keyword, till now we are saying list keyword, but what is it? It is actually the class name or the object type list. And you are saying you are passing that value to the class, which is list. And you will pass this. And when you pass this and assign to something, say lst3, so this is also a way, this is also a way you can create an instance of an object. Here, for instance, it is a list. All right. So you have defined list lst3. Sorry. Yeah. All right. So these are some of the ways in which you can create an instance of predefined objects. Now we'll see how we can create our own object types or classes. All right. So creating and using your own types with classes. So classes are implementation of objects in Python. So Pratibha, can you speak now? Do you have any questions? You interrupted me for a while earlier.
No, sir, I could not hear you. That's
All right, all right.
why. Yes.
So it is important to distinguish between creating and using an instance of a class. So when we were implementing functions, we discussed that there are two ways to look at functions. First is in a way that you are creating that function. You are the developer of that function, and in the second form that you are using the functions and but you are not bothering about the implementation of the function. Similar to that, here you can look as classes or objects two ways. First, you are creating the class, and second, you are using that class. So first we will discuss how we can create a class or how we can create object types in Python. Then we will see how we will create instance of that object type, that is known as objects, how we will create objects of that object type and then use those objects. All right. So defining by class name, defining by attributes, and we will see. Someone wrote the code. Yeah. All right. So we'll see how we define a custom class. All right. So the keyword when we define functions was def. For class, the keyword is actually class. All right. So we'll say class, and suppose the name of the new object is not name. I should refrain from the word name. So it is not the name. It is object type. So the type of this new object is new object. All right. And you can say pass. So in previous classes, we told what pass is. Pass is just saying to Python that I'll write the code little later. All right. So I'm just saying Python that just don't give me an error. I'll write some code a little later. All right. So what I'm doing here, I'm creating a new object type, which is new object. So new object is a type. Similarly, when I say class employee, then that will be the type of the object. Employee will be the type of the object. So let me run this. So you see you have an object created in the memory, and inside this you should have some attributes. I have not defined the attributes here, but the type of this object is new object. All right. Similarly, you can have some students class. So you can say student as student class stu, and it has some attributes. I'll just write pass for now because we are just discussing how we define some class. So you see this class has a, or this object has a type which is student. All right. So when we run this, we see that it is defined in memory and we are not getting an error. All right. So I've written similar to def. This class is the keyword to define objects, and indentation is important. All right. the term object signifies that new object or obj. I'm written obj. Acha, is a Python object and inherits all its attributes. So when we define some attributes, let me define some attributes for a class. Suppose I have a class, say coordinates. So you see, in Python we have sets, we have lists, we have dictionaries, and so on. But we don't have some data type called coordinates. So in Cartesian coordinates, suppose 2 dimensions, we will have something like this. So we will have a coordinate, say x comma y. All right. So this is the form of a new object we want to define, and we want to perform some operations in this. So suppose I want to get the distance between two coordinates. So x1, y1 and x2, y2. In this class, which has a type of coordinate, we can define the method called distance, and we can use those methods to get the distance between two objects. So I'll show you this with list. So suppose I have list 1. So what is list 1? This is list 1, and I have list 3. So these are two lists. And how we call methods inside the object. So we do that by saying list 1 dot, suppose I'm saying extend lst3. So what are we doing is, you see, this list 1 has some methods defined for that object type, which is list. And one of those method is extend. All right. In this extend, I'm passing a argument, which is also an object. You can do that. And this extend will perform some operations with the object called, or instance of that object called list 1. This extend is defined inside that object. Similarly, I want to define some method called distance, which takes two coordinates, that object we created called coordinate, and gives you the distance. So what extend will do actually? It extend the list 1. So if you implement this and see lst1, you will get this. lst1 is changed to something else. All right. So this extend is a method defined for that object type called list. Similarly, I want to define a method called distance. It implements on two new object, which is coordinate, which we have defined, and it gives you the distance between those coordinates. All right. I hope you understood what I want to do. Is it clear? Why are we defining a new class called coordinate? Because there is nothing called coordinate in Python, and we want to use this class or this object for our suppose mathematical application. I want some data type called coordinate, and I want to perform distance operations many number of times. That is why I'm defining some data type called object, which is a coordinate, and we will perform some functions specific to those coordinates later on in our project. Suppose that is why we are defining an object called coordinate. Is it all right?
Yes, yes.
Pratibha, is it all right? Are you here? Ashok, are you here? All right. So either you are not here or you are not, you don't like my voice, maybe. All right. So we have seen how we define an object type. So here we defined an object type. So when we go back and see, object has a type, it has some representation of data, and it has some uh, methods through which we can interact with those. All right. So, and these two together, internal representation and methods, are actually known as attributes in a class. All right. These two together. So that is what I have written here. So till now we have seen how to define a class object type. All right. Now we'll see the attributes in a class. So attributes in a class can be of two types: data attributes and methods. All right. So data attributes consider data as other objects that constitute a class. For example, a coordinate class may have two numbers as data attributes. So similarly, I said X comma Y. You can have three attributes, X comma Y comma Z, and other attributes as well. All right. So for employee, when we are saying, so it can have attributes like name of the employee, address of the employee, marital status, and so on. So those are data attributes of the object called employee, object type called employee. All right. Now methods, as we have seen when we are talking about extend, extend is a method, and these are actually functions, but it is specifically to this class object. That is why it is known as methods. All right. And method define how we interact with that object. For instance, you can define a distance between two coordinate objects, but there is no meaningful distance between two list objects. Why I have written this line? Because it indicates that that method is very specific to that object type called coordinate. It has no meaning for other data types called list, such as list, tuples, etc. All right. Now we'll see how we define data attributes for our class called coordinates. So we'll again define. So I have defined the class here called coordinates, but I'll redefine it. It will not give an error. All right. So I'll say class coordinates, and I'm giving a colon, but you can give a parenthesis and you can pass inside something. And what is that? We will talk about in the next class when we talk about inheritance. All right. So in the previous code snippet, I have not run it. Let me run it. Okay, I have not given pass. So here I have not given parenthesis and any thing inside that parenthesis, but you can do that. And for now, I am saying object. All right. What it means, what it represents, we will see when we will talk about inheritance. But if you don't give parenthesis object, it will work. So nothing to worry about. If you don't give parenthesis object, it will work. But what it represents, you will know when we talk about inheritance in our next class. All right. So let me not give it. I have told you for the sake of completeness. Now we have defined the object type, which is coordinates. What do we want? We want to define data attributes for this um, object type called coordinates. How do we do that? So to define how to create an instance of an object, we use a special method called underscore underscore init underscore underscore. This method is responsible for initializing data attributes. Right. So we will define a function called underscore underscore init underscore underscore and pass some arguments. We'll see what those arguments are. But for now, let us understand what this is. So you see, whenever you have init, so this is actually in any class or in any functions in any class. If you have this function, this will be run first. All right. So this will be the first function which will run when you have a class. Now inside this class, so before that, you see, I'm just repeating this again and again because it is important. All right. So coordinate is not an object. Coordinates. I have written coordinates. Let me write it. Coordinate is not an object. Coordinate is an object type. You can create different objects of type coordinate. Similarly, when you have list, so list, when we were saying here list, so this is not an object. List is an object type. All right. List is an object type and lst1 is an object of type list. You can also say lst1 is an instance of type list. Both the things are same. lst1 is an object of type list or lst1 is an instance of type list. All right. Both the things are same. Now, when I say here coordinate, coordinate is an object type. All right. And we are defining some attributes for that type. We haven't defined any object yet, or we haven't have any instance of this object type called coordinate. All right. Now defining this attribute, data attributes. You see these three, I am passing three here, three parameters or arguments: self, comma, x, comma, y. All right. So x, comma, y, we know these are the coordinates. over here I said x comma y will be the coordinates x and y. What is this self? Self is a placeholder for any instance you define. All right. So when I was saying LST1 and I was saying LST2 and I was saying LST3 and so on. So these LST1, LST2, LST3 will go to the class of list. So in that place, this will be list, and this self will take any value you are passing. So you are saying LST1. So self will take LST1. When you're defining the instance LST1, when you're defining the instance LST2, then self will take LST2. Similarly, when you are saying LST3 equals to something, then LST3 will be passed to, not passed, it will actually self will is a placeholder of that instance. Self is a placeholder of that instance. All right. And this can be named anything, but it should be the first parameter of any function inside a class. It should be the first parameter of any function inside a class. What does it mean? It actually is a placeholder of the instance of a class, of any instance. Any instance you define, it is a placeholder of that instance. Now, when I say self dot x, so let me write it as x1 and x2. It will be better. X1 and y1. All right. So we are getting, so when you are defining this instance of this class, you are passing. So over here, I'm passing this list, or over here, let me go over here. Yeah. So when you are saying list bracket and you are passing this thing 2 comma 3 comma 4, this is one object. All right. So this list is one object. This will be passed to over here x1. So whatever it is in list, you can check. Let us do that. Actually, you can check help list and you can run and you see class list, and inside that I told you object. We'll see what that object is, and inside this class you will have init. You see init, and the first argument of all the functions which you see inside this class, or all the methods which you see inside this class, is self. All right. And you have two more arguments s, and so we have talked about what are these keyword arguments and arguments. Let us not go into that, but what I'm saying is these are passed to that um, init function. So when you say list and pass something, this will be passed to the init function. All right. Sorry. Yes. So self dot x. So I'm defining one attribute x to coordinate class, which will take the value of whatever you pass. So if you pass 7, so it will take 7. So x1 is just the variable name, and this variable, whatever the value, suppose you're passing 7, so the 7 will be stored in x coordinate. All right. And when you say self comma dot y, and it takes the value of y1, so what it is doing is whatever the value you pass to y1, it will be stored in y. All right. Y is an attribute, x is an attribute, x1 and y1 is not attribute. It is just variables which you are passing, or parameters you are passing when you are defining the instance of the object. And this x and y are attributes of the coordinate type. So you will understand. Just let me create an instance. So suppose I am saying C is a coordinate. So how do you create an instance of a class? So over here, I have defined a class. Here, I will create an instance of a class. How do we do that? You say coordinate and you pass the number of arguments it requires. So you see, you will say that it requires 3 arguments, but it will not require 3 arguments. Why? Because this self is actually, yes, this self is actually a placeholder of that instance. So this C is an instance. So this will not be required. You don't need to pass anything for self. This C actually will be passed in place of self. You just have to pass 2 values. Suppose I'm saying 3 comma 4. All right. And when I do that, then you have created an instance of class coordinate class type coordinate with values x and y. All right, you can check, by the way, you can check c comma x. So you can say print c dot x. So when you do that, you are saying this object, which is c, has some attribute called x. I know that. You shouldn't know that, but since we are implementing, I know that there is something called dot x in that class. And what is the value? You can check. It is 3. All right. So this x is an attribute of coordinate class. X1 is not. X1 is just a variable or argument which you are passing to that object. All right. So x1 is taking value 3 and it is storing it to the attribute called x and y. All right. Similarly, you can have another coordinate called origin, which is coordinate 0 comma 0. And when you do that, then you can get print origin dot x, and when you do that, you'll get 0. Any question? So what we have done, we have created an object instance, not or instance. We have created an object and defined it at data attributes, and we have created an instance of that class. So we used to do this when we were saying lst equals to list and passed something, say 1 comma 2. So we are doing the same thing over here. We're doing the same thing over here. I'm defining the type, I'm writing the type of that class, and I'm passing the arguments which is required. Similar to what we did earlier. We wrote the type, which is list, and we passed the argument which is required. It required one list inside it. And then we had created an instance called list. So when we checked print type lst, when we did this, we got class list. Similarly, when you do this for this c, you say type C, you will get class main dot coordinate. You don't worry about this, but it is saying it is of class coordinate. All right. Is it all right?
Yes, sure, yes.
Pratibha Ashok, is it all right? Are you here?
Yes, sir.
Any doubt? Because I am again and again repeating object, 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 and it may be confusing. Is it clear? All right. So Ashok, are you here? All right. So you see, uh, we have created an ob. So when we go back, we have, so when we are here, we have actually defined the class name, which is actually class type or object type. We have defined one attribute, which is data attributes. We have not defined the methods. We will do that. And we have also used the class. What we did, we created an instance of that object. We created an instance called C. This is one instance of that class. We created another instance called origin. This is also an instance of the object called origin, object called coordinate. All right. Now we will come here and we will define the method attributes. So if you see, it has data attributes and it has method attributes. And when we are talking about coordinates, we said we wanted to define a method called distance, and what it will do is it will take two coordinates and it will give you the distance between those coordinates. All right, then now we will define what methods are. First, let us define what methods are. A method is a procedural attributes. I have written over here. So procedural attribute. All right. Similar to functions that operate specifically on instance of classes. In Python, methods are defined within a class and are called instance and are called on instance of that class. The first parameter of the method conventionally is named self. So you can name it anything, but conventionally it is named as self. And it represents the instance on which the method is called. So this is important. When we are defining C, self was taking value C. When I am defining origin, this instance, it will take origin. All right. So it represents the instance on which the method is called. All right. Now, we talked about this dot operator. This dot operator is used to access the method and attributes of the. So it is used to access both. It is used to access the method as well as access the data attributes of an object. Over here, when we said origin dot x, we actually accessed the data attributes. We can also access the methods using this dot operator. All right. It allows you to invoke the behavior or retrieve the values associated with that object. 1 minute. All right, so we can define some uh, methods and you can call those methods. So let us define a method for this class called coordinate. All right, and I'll redefine it. It is not an issue. All right, it will just override the above one. So I have defined one uh, object type called coordinate, and this is the data attribute of that object type. And I want a method for this object called distance. So I'll say def and method name. Suppose I'm saying dist. I'm just saying dist. All right. And I told you the first the parameter of that method should be self. What it represents the instance of that class. All right. And I want another object which is of type coordinate. That is what you want. Now you want two objects of the type coordinate and you want to take the distance between those two um, coordinates. So first we have self. I want another parameter which will be of type coordinate and I'm just naming this other, right? So here when I was saying x1, it was taking a object which is of integer type. When I'm saying other, I am expecting that this other will be of type coordinate. All right. So when I'm saying x1, I am expecting it to be an integer or float also. It can take a float value, doesn't matter. But here, when I'm saying other, I am expecting that this other will be of the type coordinate. All right. Now I'll take the Euclidean distance. If you know that it is x1 minus x2 whole square plus y1 minus my y2 whole square and under root over all those. So if you don't know, you can just check the distance between two coordinate or points. This formula is there. So x1 y1 is the first coordinate, x2 y2 is the second coordinate. All right. So that formula I want to imply, it's mathematical, but how it is we are doing it, it is important. So I'm saying x difference. So I'm doing it separately. So I'll just do this first, x2 minus x1 whole square, which will be stored in variable called x difference, and y2 minus y1 whole square will be stored in another variable called y difference. All right. So I'll say x difference. And how will we do that? You see, the first point is self. So I'll say self dot x. We have used dot x earlier. You see origin dot x. So we can do that minus other dot x. So I'm saying this will be the x coordinate of the first point and I'm saying this will be the x coordinate of the second point. And I know that other will be of type coordinate. That is why we can do that. If you are passing some other object to this function, then it will give you an error. So I am assuming that you are passing the correct uh, parameter. All right, and I'll square it. Similarly, I'll say y difference and do that again, self dot y minus other dot y, and it is again self and it is 2. All right, and I'll return what I will return, x difference plus y difference under root. So I'll say under root by 0.5. I guess this is all right. This is the same formula. That is what I am returning. All right. So I'll just execute this. Now you see we have defined two instances of coordinates C and origin. but that was defined for the class coordinate, which is defined here. All right. And this class did not have a function called distance. So it will not work. You have to define again. Why? Because we have updated the class coordinate. All right. So I'll just um, define the instance again. So I'll just write it again. So this is the first instance and this is the second instance or second object, whatever you say. Now, what I want is I want to take the Euclidean distance between two points. You can do that using the dot notation. So I'll say print. So on which object you want to apply will come first. So suppose I want to take the distance between origin and C will be the first point. So I'll say C dot dist and I'll pass the second object, which is origin. All right. So what I did on this instance, I am applying dist. And when I do that, then C will be sent to self. Right. And whatever you are using the dot operator, that will be sent to self. And this will be passed to this. All right. And when you do this, then you will get the Euclidean distance. What is the Euclidean distance? Which is 5.0. Any questions?
No, no.
You can also do that using one more, what I should say, way. So you can do that by doing the class name. So first you have to write a class name dot the function name or the method names. Class name dot method name and then pass the two arguments. So this is the way we do in general when we pass some arguments to the function. You see, first the class name dot the function name and it expects two arguments here. So over here you have to pass two arguments, C comma origin, and then you will be able to get the same thing. Sorry, origin is not defined. Origin, yeah. All right, so this and this are same thing, same implementation, but we prefer this because we don't have to write the class name. I'm just writing the instance name dot the method and then pass the other parameters to those method. All right, so this and this is same. Similarly, when we are doing list extension, you can do that. List dot extend and pass to list lst1 comma lst2. I hope I have those two lists and this will be passed to self and this will be the argument to extend method. All right, and when you say lst1 you will see that it is extended. You see it was still here. If you go back lst1, where is lst1? Yeah, so it was still here 7. It is extended again. This extended till here. All right, so you can use methods like this as well. All right, so I'll just take this a little bit above because I wanted to have the heading. Yes, and how to use the method. How to use the method will also go above. Yes. All right. Any doubt? So we will take 5 minutes break and we'll meet at 7:02. 7 minutes to 7 hours 2 seconds. 2 minutes 7:02 and then we'll move forward. All right.
Okay.
Okay.
Yes, so we are back. Yeah, so just 1 minute. Yes, so you see, we have defined methods and we have called instances. So let me see what we'll do next. So you see, when we are calling this anything, suppose we are saying that print and I'm saying any instance. So first I have lst1. So let me see what it will do. Print lst1. So it is printing me the list. All right. So I'm getting the list over here. Similarly, if I want to print C, so let me see what it is printing. So I'm saying print C. All right. So you see what I did. Before that, what we did, we created a object. We defined its data attributes. We defined the method I want to use with that object, and we created instances, C and origin, and we use that method also. Now what are we doing? We are seeing that I'm have a instance called lst1 and I'm printing it. So when I print, I get this. All right, I'm getting this. Now let us see what we get when I say print C. So when I say print C, I'm getting something called main coordinate object. So what is this? It actually says that it is an object of coordinate type, and this is the memory location. So this is what it says. All right, but this is not very pretty. It is uninformative and not a good representation. So you want to have something like this such that the user sees what C is. So for that also you have to define one more method called underscore underscore str underscore underscore method. All right. So let us define it. So I'll take this definition of the class and over here. And you see, you may choose to represent it anyway. So the developers of Python chose to represent list this way. Similarly, for coordinate, since we have defined this object, we can choose to represent it anyway. All right. So I'll say def underscore underscore str underscore underscore, and the parameter should be self. We have talked about this, and you can uh, represent it anyway. All right. So let us represent it in this way. So I want to represent it. Suppose a coordinate like this. So x comma y. This way we want to represent a coordinate. So it is your choice. You can do it anyway. I am doing it like this. You can also do that like this x comma y. But you see, you people may get confused that it is a tuple or a coordinate. So that is why I am using this arrow bracket. You can say arrow bracket to represent a coordinate for our object called coordinate. So how will you do that? You have to just pass the string. All right. So you say this less than equal to sign plus str self dot x plus you should have a comma. So you see you're just going this way. So you have defined till now you want a comma. So you give a comma, then plus, then str self dot y, and then plus less than equal to sign. Right. Sorry, less than equal greater than equal to sign. All right. So this is how we want to return. So whenever someone calls it by print that instance, we want to print it this way. So when you define it this way, and when you say C equals to, so I have to define it again because this C was defined for the previous object type called coordinate, but I have defined it, I have changed it. That is why I have to redefine it. All right. So I did this. Now when I say print C, you will get a very pretty representation. It is up to you. You can change it in any way you want. All right. Any doubt? All right. Now, when we had list, so when I had list 1 plus list 2, so for list, it actually extended the list. So it returned something which is an extended list. So this list and this list. For string, so suppose I had s1 as hello and s2 as Shubham. And when I said S1 plus S2, it returned a concatenation of the both the strings. All right. Hello, Shubham. So these two plus are doing different things. You see, over here it is actually extending, over here it is actually concatenating. How does Python know कि when I'm using plus with string object, I should do concatenation. When I do plus with list object, I should do extend. How does it know? It is actually defined inside the object definition. All right. And these are the special operators you can use to define the um, special operators which you what you want it to do. So the special operators are plus, minus, double, equal to, less than, greater than, len, print, and many others. All right. So when you say s1 greater than s2, so what does this mean? What is greater than for string? It is defined inside the object. You see, when you I'll go back, I'll go there. So it is saying true. So what does this mean? We know that it is checking alphabetically, but how it is defined? So it is defined using these functions. All right. So whenever you say one object plus another object, this function is called underscore underscore add underscore underscore. This function is called. And what it will do, you can define it. Similarly, when you define similar to the way you defined str. So you can change it. Suppose I am saying this as this bracket instead of less than bracket, I am saying one will be less than bracket and one will be this bracket. So when you do that, you see your representation changed. So it is up to you. You can change as you want. So similar to that, when you are defining this add function underscore underscore add underscore underscore, you can define what this plus operator will do. So for list, it is defined that extend and return a list. So for string, concatenate and return a string. It is defined in that manner. So for coordinates, this object which we have defined coordinate, you can define what plus will do. You can define what minus will do. You can define what greater than sign will do. You can define what less than sign will do. All right. So you can define what these operators will do. So let us give one example. So suppose for coordinates, when I say x1, so it is just for explanation. All right, x1 y1, and I'm saying plus x2 y2, x2 y2, then we mean what do we mean? We mean that we should get x1 plus x2 comma y1 plus y2. We want to get this. I know it doesn't mean anything for coordinate system, but let us say we mean this. So how will you implement? You take this definition and define this. So for addition, the function that will be called is underscore underscore add underscore underscore. So let us define that function def underscore underscore add underscore underscore. And I want two objects that will work with add. So I'll say self comma other. All right. And what should be the what do we want with this add? We want to return this. So I'll say self dot x plus other dot. So let me do it separately. So x will be x part will be self dot x plus other dot x. All right. And I want y part as self dot, just 1 minute. I want y part as self dot y plus other dot y. All right. And what do we want to return? You see over here, it returned a list. What is list? List is also an object of type list. All right. It did not return a integer. it returned a list. Over here, what do we want to return? We want to return a coordinate. It shouldn't be a list. It shouldn't be a tuple. We want to return a object which is of type coordinate, and that coordinate we have defined. So that return value will be another call to this object. It is not a call. I use the word call, but it is not a call. It is a instance of that object type, which is coordinate. And you will pass what you will say. You will say x part comma y part. X part.
Spelling.
Okay. Okay. Coordinate x part comma y part. All right. So what did we return? We returned an object of type coordinate, an instance of that type of the type coordinate. All right. And when you run this, and again, I have to say C equals to, so let me copy it, coordinate 3, 4. So C equals to coordinate 3, 4. And let me define one more. So D equals to coordinate say 5, 4. All right. And then what I will do, I'll say C plus D. So when I say C plus D, what it will do, it will add 3, 5, which will be 8, and 4, 4, which will be 8. So when you do that, you will get, okay, I'll have to print, I guess. Let me see why I'm getting this. Yeah, print. Yes. So when you say print, then it will go here and it will print it this way. So we'll have 8, 8. Any questions? So you can have special operators. So I'll just move it above. All right. Any questions? So similarly, you can define what minus means, what equal to means, what less than means, what greater than means, what len means. So len is also defined. All right. So I have said what str is, and there are others also. So I have given some link, I guess. Okay, this link has some documentation over here. When you come, you will see others also. So this is str. Again, you go down. This is add, sub, multiply. So you can have multiplication also, division also, power also. You can define what it means. So what is a object, power object? So you can define that and so on. All right. Is it okay? Yes, Pratibha, you have a question, I guess. You're raising your hand.
No, sir. Sorry, sir.
All right. So, and yeah, now why I have written it this way, you see, you can read what the source code of this str is. So str is a object type. So you can check also. You can say print str. And when you see it is a class of type str, and you can see what is the code is. So this is actually the doc string. All right, this is the doc string. And these are the methods. So add method, contain method, equal method. So what does it mean when you say equal and other methods are there? You need not go into all of these details, but for understanding, because we are talking about all this, so you can see there should be an init method. Where is it? There should be an init method. Mm. I'm not getting it, but there should be an init method, right? I don't know. I'm not getting it. Okay, it is here for list, but I'm not getting it for string. Why not? It must be there. And if not, I'll check, but it should be there. All right. So this is how objects are defined in Python. So you can understand how these inbuilt objects are defined, str, list, and so on. All right. Now, what is the advantage of using object-oriented programming? All right. So you see, when you are doing this, you are building objects in some packages, and you can use those codes again and again. So this facilitates code reuse. building package data into packages. So you can define your own data type. So if you need some data type for your work, for your project, for some other work, and you want to use some functions with those data types again and again and again, then you can define your own data type. You can divide and conquer. So what does this mean? You see, these different functions are there. You can have modularity of code, the behaviors of separate classes. So if you have different data types, you can also go and check the different data types. You need not write all the code in one place and then get confused and so on. And what inheritance means, we'll see. I'll give you just a hint. It can be parent classes and subclasses. So there can be a class called animal, and in that animal we can have subclasses. So there can be humans, there can be cats, there can be rabbits, and in humans there can be more subclasses, adults, childrens, and so on. So these are all inheritance. What does it mean? The animal, so the human subclass will inherit all the characteristics, all the attributes of animal class. The rabbit subclass will inherit all the attributes of animal class. Similarly, some cat class is there. It will inherit all the attributes of animal class. So all the functions, all the data representation, everything, it will be inherited. Similarly, in humans, we have subclasses called adults and children. So those two classes will also inherit everything coming from above. So it will inherit animals also, all the attributes, and also from humans. So human can have an attribute that they can speak, they can move, they can work, etc. Cats can have attributes like they can say meow, they can also move, and so on. All right. So these attributes are inherited from one parent to the children. That is why inheritance allows subclasses and redefines on extent. So inheritance is important, and we'll see how inheritance work. All right. And yeah, so we have also seen some modules. So when I say module random dot random bracket, so let me show you what I mean. So I'm saying import random, and I'm saying random dot random, and when I do this, I get some random value between 0 and 1. So this dot operator is working in the same way. This random is a module which has some function in it called random. Sorry. And that is why you are able to use those function here. All right. Now I have given two examples. One is fractions and one is set. And let me tell you, I have copied it exactly from MIT course. All right. So this is not my work. I have not written this code. I have copied it exactly from here, this course. But it is very good example of what we have done today. All right. So you see, like we have implemented our object as coordinates. We can also have an object called fractions. All right. What is fraction? So it is a type. It will have a numerator and denominator, and it will be represented by numerator by denominator. So in Python, when you write some fraction, so let me show you. When you say 3/4, it will actually give you decimal value. It will not print 3/4. And I want some representation of that data as 3/4. That is why I am implementing this um, object called fraction, which will represent 3/4, and we can perform some operations. So what are the attributes of this object? It will have a numerator, it will have a denominator. So these two attributes, I guess, are sufficient. All right. And what functions do we want to do? We can do addition, we want to do subtraction, and we also want to convert it into float or decimal, and we can want to do inverse. So if we have 3/4, I want to inverse it and get 4/3, so on. So some more functions you can think of it, but these are some of the basic functions I want for our object called fraction. All right. So yeah. All right. So first of all, we'll define init. And in it, we have three parameters: self, number, and denominator. So we have not talked about this object, but let me do it because we are in a position to discuss it as we have discussed what inheritance is. So you see, we have talked about inheritance. So from parent class, some attributes are getting inherited to subclasses. All right, or yeah, subclasses. So object is the most basic ob object type in Python. It is the most basic object type. It has some attributes like addition, subtraction, and so on. All right, it is the most basic. And whenever we define a class of this, whenever we define a class type with an attribute object, it is the basic class we are defining. So when you suppose for the example, when we are saying animal, then it has subclasses like humans, cats, dogs, rabbits, and so on. So the basic was animal. So animal was the basic. Inside that, it has more sophisticated classes. So first, when we'll define animals, we'll say class animal, and the attribute, or not attribute, sorry, it will inherit the attribute of object type. So object is the most basic class in Python. All right. Now, when we define a subclass called humans, the attribute, or yeah, the attribute it should inherit is the object type animal. So inside that bracket, I'll have to write the type, which is here animal. Similarly, when I define class cat, inside this bracket, I will define the parent class, which will be animal, and cat also it will be animal. Now, for humans, we had two subclasses. One was adult and one was child. So for adult, the parent class can be human. So in this bracket, I should write the class type as humans, and so on. So this is why this bracket is important. It helps in inheritance. All right. And when you don't give anything, if you remove this, then Python will think of it as the basic inheritance of object type. All right. Now let us see how this fraction class is defined. First of all, we have discussed a lot about this object-oriented programming. Have you understood, or was it too much? You can speak.
It was a little bit difficult to understand, but yeah, I got the crux of this topic.
Okay, so Kalyavani ma'am, you joined later. Did you understand?
Yes, sir.
All right. So are you familiar with object-oriented programming?
Yeah, I have handled the Java and C++.
Okay. And Ashok Vardhan?
I've handled Java and C++, sir.
Yes. Thank you. I was asking Ashok. Ashok, are you here? All right. So let us see what is the implementation of this object called fraction, or object type called fraction. So first we'll have init. So in that, and yeah, in exception handling, we have not talked about this method called, or this statement called assert. So what does it do? Let me show you in simple terms. So assert actually accepts a assert. Assert actually accepts a Boolean expression. All right. And if it is true, it will not raise an error. Otherwise, there will be an error. All right. So it is in exception handling. I did not do it because I don't know. I skipped, or maybe I did not. Um, yeah, I did not stumble upon it. But assert actually is a topic of exception handling. So it accepts a Boolean expression. So let me give a Boolean expression. One is greater than two. So let us first give a correct or true Boolean expression. Two is greater than one. What does it will see? It will check if this Boolean expression is true or not. If it is true, then it will not do anything and just remain a useless piece of code. If the Boolean expression is true, if the Boolean expression is false, then it will raise an error. So let me give a print statement, say 3. Now you see this Boolean expression is true here because 2 is actually greater than 1. And when you execute it, this will do nothing and you will get 3. But instead of this, if you have a false Boolean expression, 2 is less than 1, then it will raise an error, and the next statement will not be executed and you will have an assertion error. All right. So this is what assert does. And you can do it with try and accept, and you can accept that assertion error. We have talked about this, and if you don't remember, please go back You can put assert inside the try block and you can accept an assertion error, and then you can handle that assertion error later. If you're not getting what I am saying, please go back and read that part. All right. So yeah, so why have they put assert here? Because they want to assert that the numerator as well as the denominator is integer. They don't want decimal in numerator and in denominator, but they have not handled the error. So in case someone puts some decimal, then the program will stop. It will give an error. All right. So they should have put it into try and accept, but for the time being, let us assume that the input is actually an integer for both numerator and denominator. All right. Now in init we have self.num, which is taking the numerator value passed from the user and denominator as denom from passed from the user. All right. Now the underscore underscore str underscore underscore actually helps in printing or when you say str. So it is two ways. All right. It will either help in printing. So over here when we were here, yeah, print C plus D. So it actually helped in printing. It also helps when you do this str C. I guess this will work. Yeah, over here also it helps. That is why the function is called underscore underscore str underscore underscore. It is actually something related to string, and print actually accepts. Actually, it not accepts string, but it is better to pass string there. All right. So that is why this function is called underscore underscore str underscore underscore. So let me go here. Yeah. So we'll print it like the numerator plus forward slash and the denominator. This is how I want to print a fraction. The numerator forward slash or the denominator. Now when we add two fraction, what addition does in fraction? We will take the numerator and denominator separately. For the denominator, we will multiply the denominators, and for the numerator, the first fraction's numerator multiplied by the second fraction's denominator, and the second addition, the second fraction's numerator multiplied by the first fraction's denominator. It is just a fraction addition, not complicated. So I'm taking the top and taking the bottom, and then what I'm doing is return an object which is of type fraction. This is important. This is similar to what we did when we were doing this underscore underscore add underscore underscore this thing. What are we returning? We are returning a here coordinate object. Over here we are returning a fraction object. That is why we are returning fraction top comma bottom. All right. Now when we have subtraction, then it is just fraction subtraction. It is not difficult. The mathematics is simple. What we are returning is fraction top comma bottom. All right. When it is float, then we are just returning numerator by denominator. All right. And when we are inverse, then we are saying we will return a fraction object when we pass the denominator as the numerator and numerator as the denominator. That is a very simple, this very simple implementation of an object called fraction. So this will be the instance. First is A, then is B. So we are saying 1 by 4 and 3 by 4 is what A and B is. Now we'll do A plus B. You see this plus will go and check what underscore underscore add underscore underscore is, and it will store it in C. All right. And C will actually be a fraction object. All right. C will not be integer or anything else. It will be a fraction object. And when you print C, you get 16 by 16 because when you do the mathematics which is implemented is in this function, it will actually be 16 by 16. That is not important. The point is when we are doing this operator, this function is implemented. This is important over here. All right. Now when we do float C, you see we don't have float function in Python. We don't have anything called float or not function, sorry, float data type. We have integer data type, we have string data type and so on. We don't have float data type. But for this fraction, we have defined a function called underscore underscore float underscore underscore. And how is it called? It is just called by float bracket. So in this way, we are converting that and we have defined how it will convert. So this is how it will convert. You can do anything. You can just say +1. Although it is not correct, but you can do anything. It is not important that it should be what it says. You can change it in any way you want. But you will get this float C. All right. You can also get it by, we talked about this, the class name dot, the function name over here. You have to say underscore underscore float underscore underscore and then pass the instance. All right. You can also do float. So this is actually a compound operation. What it is doing is, first this is doing b dot inverse. So whatever b is, it will inverse and it will create a new object called fraction self dot denominator. And that object will be passed to this function called float. And then this is what you will get. And if it is confusing, let me go back and show you using Python tutor. That will be very good. So let me do a simple one. Let me take this and go to Python tutor. Not this, sorry. Python tutor. Just paste it here. This is the class definition and this is the instance. These are the instances. All right. And let me take this also, print C plus D. This will make things more clear. So am I audible? I'm speaking a little at low voice. Am I clear? Am I audible? Hello?
Yes, yes.
Yes. All right. So this is one implementation of the what we have talked about. So let us see what it happens. You see, when we define this object, it is created in memory. This object is created and all the functions are there. So it has add, it has init, it has str, and it is also has something called dist. All these functions are there. It is not checking what those functions are doing, but it is there in the memory. Now this first instance will be created. You see, this is the global frame and we don't have any local frame because we haven't defined any functions yet, or we are not inside any function yet. Now this instance will be created. What this instance is? This instance is C of the type coordinate. So you see what happens. This instance, which is not named yet because it has not been stored in C. Whenever it will be stored in C, then only it will be named at C. But this instance is created inside the memory init. And the instance is of type coordinate. All right, coordinate instance. You see, it is written clearly. It is a coordinate instance. Now inside this coordinate instance, we are passing x1 as 3 and y1 as 4. We haven't defined the instance value of x and y yet. You see, it will be defined now. When you go, you will have this instance have a attribute x, which has a value of 3. Similarly, it has an attribute of y, which is a value of 4, and this will be stored. Now this value will be returned to C, which is actually the name of the instance. So this is the instance and the name of the instance is C, which is in the global frame. So it will go back in the global frame and C will point to this instance in memory, which is of the type coordinate. And it is an instance of the type coordinate, which has value x as 3 and y as 4. All right, again, D will be there. So there will be an instance inside the memory coordinate instance, and then the value will be passed. So what will be passed? X5 will be passed. And so before that, x1 5 is passed and y1 4 is passed. Now inside the instance, the attribute x takes 5 and y takes 4. And this value is returned to the global frame with the instance name called D. So this will be returned to D. Now we will go to addition. So when we have C plus D, just 1 minute. When we have C plus D, then it will create one more instance in memory. Okay, it is not creating an instance because the return statement is not encountered, but it is going to that frame, local frame. And then self is pointing to this instance, C instance, and other is pointing to this instance, T instance, or the name D, that instance. Now it will do X part. All right, so it will go and it will do X part. So X part is 8. It will do Y part. Y part is 8. Now when I am returning, so be a little bit serious now, or careful now what it is doing. You see, currently we have two instances, this instance and this instance. All right, we don't have a third instance, but now this line coordinate x part comma y part will create one more instance in memory. All right. This will create one more instance in memory, coordinate instance. And what will be passed? X part and y part will be passed. What is x part? 8. So you see 8 is passed to x1 and 8 is passed to y1. Now x self. So this new instance has the value of 8 of the attribute x, and this new instance for y has a value of 8. And this, whatever this is, will be passed to print. I have not assigned it, so it will not be in the global frame, but it will be printed. All right. So the return value of this function return value will be this object in memory, and it will be. Acha, when we do print, then str is called. I told you just now, when we do print, then underscore underscore str underscore underscore is called, and this self will be passed to this underscore underscore str underscore underscore, and then this return will be there and print will just print it. It will return this value, this string. This is string. It is not a value. It is a value, but it is not any object. It is one string, which is something less than sign 8 comma 8 greater than sign. It's just a string, and this will be passed to print, and this you will get as output. And whenever this is as output is printed, you don't have this in memory because you have not stored this in memory. If you would have stored this in memory as E, then this would have been there in the memory and one instance would have been created 888. All right, so this is lost in the memory. Any questions? So you can have a little bit extension of this code. You can say DEL, DELC and DELD. So when you do that, then those things will also be removed from the memory. So when you do that, when you come here and to print this 8,8, when you print this, now this del C and del D, it will delete that thing from memory. So this is erased from the memory and this is also erased from the memory, and the memory is cleared. Any questions? Any questions? No questions. All right. So you see, we have an object called set in Python. We have an object called set, but we want to create one more object called inset, and we want to perform some operations which are not defined in set, or maybe defined in set, but still we want to uh, perform some of the operations which are not actually defined in set. Suppose we want to only have a set with even numbers, something like that, or some other thing you want. So that is why this set is int set. It will only have integer values in the set. So what Python has is it can have any value. It can have strings, it can have other values as well, I guess decimals also. But over here it wants only integer, I guess. Why int? I don't know, but this is an object in Python. All right, yes, a set of integers. Now we will see what this int set is. It has a initialization which is I. So I underscore underscore init underscore underscore is actually initialization. That full form is initialization. All right, init, it is initialization. So what does it do? You see, whenever a new object is created in memory, or an instance of this type is created in memory, we are saying that it is a list. It is a list, an empty list. And what is the attribute? It is called vals. So earlier the value or the attribute was num and denom. All right. But now we are saying that let it be called as vals, and let that be an empty list. So earlier we saw that whatever we passed as the in the as an argument, we used it. But it may be the case that you are not passing anything, but you are initializing. So for the example of cats, you can have some cat dot color is equals to red, and you're not passing it to the initialization time. You're just defining as the value to start with. All right. So this is what it means. So whenever you are initializing a set, it will be an empty list. All right. We are saying it is a list. Now we are saying insert. So this insert function will take one value and take the instance, and we are assuming that e is an integer. We should assert, so we can write one line here, assert that e is an integer, similar to what we did here. Assert the type of this is an integer, we can do that. All right, but we're assuming here that it is a list, and we are saying if e is not in the not in, so we have used these operators, not in, etc. So what it is doing, since this is a list, it will check if e is actually there in this list or not. If it is not there, then then we are using a predefined function for the list, which is append. So we are saying just append e. So we are appending it to e. Why? Because this is actually a list. Self dot vals is a list. You see, we have defined it to be a list. And for this list, we can use all the functions which are there for a list. So we have used dot append e. All right. So whenever someone give me a value, we will append it to the list. This function member will check if if that element is there in the list or set here, but inside it, it is a list. So you see, the implementation is actually a list, but whoever is using this class is thinking, no, it is not a list, it is a set. But inside the implementation is something else. We are implementing it using list. All right. So it is returning if e is there or not. If it is there, then it will return true. If it is not, it will return false. All right. Now it will say remove. So it will do try and accept. It will try to remove if it is there, and if it is not, then it will raise a value error. So we have also not used this keyword raise. So sometimes we want to raise an error. I guess we used it in earlier class. I don't remember if we have used it or not. So when we are talking about try except block, we can write raise to raise an error. So you can give if else condition. If this is there, you raise an error. So suppose you want to ask the user for an input integer value, and the input the user is giving is something string. So it is saying some string is there. So you can raise an error. You can check if that is a string or not. So in that case, it will actually raise an error. So what I'm saying, just let me show you, it is better. So x is equals to int, say input, enter a positive number. So I'm saying enter a positive number. So this is what I want from the user. All right. Now I'm checking if x is greater than equal to 0 or less than 0, then do raise an error. Raise um let me say what error, positive and no, value errors. Let me say this positive value, or inside that we can say string this is not positive. All right, positive. And when you do this, you can give 9 and it is a positive number, so there is nothing. But when you give -9, then it will raise a error and it will say e is not, sorry. Oh, okay. So it will say string x and -9, and it will say -9 is not positive. All right, so you can raise an error if you want to, because Python will not raise an error. It is an integer and it will just cast this whatever this is to integer. All right, so you can raise some error. So here we are raising the error key not found, because if you are removing something and it is not there, we are just raising an error. And this str is just printing it in the form of something like, it will show you that it is a set. It is not a set, but it is trying to um, represent it as a set when you are printing it. All right, and before that it is sorting it. Very simple. So this is very simple. So you see, in this init we don't have any parameters, so we are not passing. We are just saying s is equals to inset. All right, so let me break this code for simplicity. So when we do this and we say print s, it will give you an empty set. And you see, actually inside this implementation, it is not a set, it is a list, but we are printing it such that it sees that it is a set. All right. Now I'll just break the code again, and we are inserting 3, 4, and 3. So 3 is inserted twice, but here we are checking if the values there in the list, do not insert it. So we'll only have 3 and 4. So let me do it. We only have 3 and 4. All right. Again, let me break this code. Okay. So we are checking if 3 is a member of the instance S. Sorry. If 3 is a member of S, if 5 is a member of S, and if 6 is a member of S. Okay. 5 is checking, 3 is checking, but over here I should break. So it is checking if 3 is a member of the set or not, and 5 is a member of the set or not. So you see, okay, it will only print 1. So it will give you true, and this will give you false. All right. Now it is inserting 6 and then printing. So let me do that. So you see you had 3, 4, and 6 is inserted, and now I'll just remove 3. So and again remove 3. So one will give you an error and one will not give you an error, because first when we remove 3, then we have 4 and 6. Now when you try to remove 3 again, it will give you an error, because we have written it like that. Raise the error of value error and say that that thing is not found. So you see it is saying 3 not found. So this is it for today's class, and if you have any questions you can ask me. I guess this Python tutor was helpful, so use this. I find it very easy to understand. Any questions from today's class? This is a very important class, by the way. All right, so let me give you attendance. So Kalyavani ma'am is here and Pratibha is here. Yes, Pratibha is here. Ram Prakash is here and Ashok Vardhan is here. All right.
You marked for Ranjit Chaudhary, I guess, instead of me.
Okay, sorry. All right. Yes, thank you. If you have any questions, you can ask me. And yeah, so we'll have actually, I was planning to have 18 to 19 classes for this course. Uh, Today's class is the 12th class, and I wanted to complete before December, but that will not be the case. And in December also, I have some commitment to a conference and other places also. So before 30th, so the next class we'll have is, so for next class, it will be on Monday, 20th. And then we'll have 2 more classes in November. So today is 12th, and 3 more classes, it will be 15. So I'll have to take 3 more classes. So I'll try to finish it by the second week of December, because I am a little bit busy. You see, I have, so these are my schedules. Okay, all right. So this first, second also I am going out, and over here also this 13th, 14th, 15th I'm going out. I have some conferences to attend, so I don't know. Let me see how we'll do. But the next class will be on Monday, and I wanted to take 3 classes this weekend. So Friday, Saturday, and Monday. So it's not Friday, sorry, Saturday, Sunday, and Monday. But I will not be able to prepare a lot. So the next class will be on Monday. So on Monday we'll do our 13th class. And I guess if on next week, in this week, if I take 3 classes, then it will be 12 plus 3. Okay, not 12, 13 plus 3. So it will be 16 classes and 2 more will remaining. So 18 classes I have planned. All right. And I have also planned to do one project. So I will do one live project with you, and you will see how we are doing it and what are the things we are implementing in that project. That will be better. So that will be helpful for you to grasp some live project work. So overall, it was planned to be a 18 hours, 18 classes, 36 hours for total. All right. So let me see. Anything else? Do you want to add? And assignment submission I have not received from many of you. Pratibha has sent me, and just, yeah.
I'm doing, sir. We'll send it
Yes.
on time.
Okay. Okay, so thank you for joining. Our next class will be on Monday and it will also be of a 2 hour class. Okay. 6 p.m. Right. Thank you.
Mm, mm.
Thank you, sir.